How can I simplify entropy of mixing calculations? Imagine mixing two different drinks and wondering how to figure out how much disorder or randomness is created. That's what entropy of mixing is all about. It measures how much chaos increases when different substances combine. If you want to make these calculations easier, there are some simple steps you can follow. First, focus on the mole fractions of each component. Mole fractions are just the ratio of the number of moles of each substance to the total moles in the mixture. For example, if you have 3 moles of sugar and 7 moles of water, the mole fraction of sugar is 3 divided by 10, which is 0.3. The mole fraction of water is 7 divided by 10, which is 0.7. These numbers tell you how much of each substance is present without worrying about their actual weights or volumes. Next, use a straightforward formula for ideal mixtures. The change in entropy when mixing is equal to negative the total number of moles times the gas constant times the sum of each mole fraction times the natural logarithm of that mole fraction. In symbols, it looks like this. Delta S of mixing equals negative n times r times the sum of all mole fractions times the natural log of each mole fraction. The natural logarithm is just a special kind of math function that helps us handle these ratios. To do the calculation, multiply each mole fraction by its natural log, then add all these values together. After that, multiply the sum by negative the total number of moles and the gas constant. This gives you the total entropy change due to mixing. If you want the entropy change per mole, just divide the total by the total number of moles. This method works well for mixtures of any number of components, as long as they behave ideally. That means they mix without any energy barriers or special interactions. For gases, you can relate volume and pressure to mole fractions using the ideal gas law, but often knowing the mole fractions alone is enough. A quick tip is when you mix equal amounts of two substances, the entropy of mixing is at its highest because the mole fractions are equal, around 0.5. This makes calculations even simpler. Remember, the key is to keep track of mole fractions and use the logarithmic relationship. This approach avoids complicated steps and makes understanding entropy of mixing much easier for everyone.